Hey everyone, and welcome back. Remember that whole Asteroid 2024 YR4 thing?
Yeah.
The one that had folks a little worried about a potential impact in 2032.
Oh, yeah. That one definitely got people talking.
Well, today we're doing a deep dive on exactly what went down, how we even find these asteroids in the first place, and what's being done to keep us safe.
And you know, what's really fascinating about 2024 YR4 is that it really shows us how far we've come with planetary defense. The fact that we even spotted it, tracked it, and then were able to calculate its path so fast, it's really amazing. It's a testament to all the systems we have in place.
That's true, but space is massive. How do we even begin to find these things? It's not like they've got, headlights on them or something.
Right. It's a total needle in a haystack situation out there.
Right.
But thankfully, we've got some pretty incredible tools and people working on this. There's a whole network of telescopes all over the world that are constantly scanning the skies, looking for anything that moves like an asteroid would. And when they do spot something, they report it to organizations like NASA's Center for Near-Earth Object Studies.
CNEOS.
Yep, CNEOS. And also the European Space Agency's Near-Earth Object Coordination Center. That one's called NEOCC.
Got it. So it's kind of like a worldwide neighborhood watch, but for asteroids.
Exactly. And anyone with a telescope can actually help out. If an astronomer, spots something that looks like an asteroid, they report it to the Minor Planet Center.
Oh, wow.
Then from there, groups like CNEOS and NEOCC, they use some super sophisticated software to analyze all the data and calculate where that asteroid's going.
So what kind of software are we talking here?
Well, there are a couple of really important ones. NASA has these programs called Scout and Sentry.
Scout and Sentry, those names sound pretty intense.
They are. It's some serious stuff.
So what kind of calculations are these programs doing?
Okay, imagine trying to, predict where a baseball is going to land after it's thrown across a field.
Okay, I can picture that.
But now imagine that the field is the size of the entire solar system and that baseball is moving tens of thousands of miles per hour.
Whoa.
And then add in all kinds of gravitational forces pulling on it from every direction.
Yeah, that's getting pretty complicated.
Right. And these programs, Scout and Sentry, they have to take all that into account. It's incredibly complex. They use these crazy algorithms to figure out where that asteroid's headed.
Wow.
They even factor in things like something called the Yarkovsky effect.
The what? The Yarkovsky effect.
Yeah, it's it's complicated.
It sounds complicated.
It is, but it's also really cool. Basically, the Yarkovsky effect is this tiny little push that happens when sunlight heats up one side of an asteroid more than the other side. Over time, this tiny force can actually nudge the asteroid off course. It's kind of like a tiny invisible thruster gently pushing the asteroid in a slightly different direction.
Okay, that's mind-blowing. So to recap, we've got telescopes all over the world, a central reporting system, and supercomputers crunching numbers to track these asteroids. It sounds like we've got this whole planetary defense thing under control.
Well, we're getting there. But it's important to remember that space is incredibly vast and things can get complicated. There are still asteroids out there that we haven't even discovered yet. And even for the ones we do know about, there's always a bit of uncertainty.
Yeah, that makes sense. Which brings us back to 2024 YR4. I remember it made headlines because, there was a chance it could hit Earth in 2032. The initial odds were 1 in 53?
Yeah, 1 in 53, which later went up to 2.3% or 1 in 43.
I'll admit, when I first saw those numbers, it made me a little nervous. But the odds have gone down since then, right?
They have, and that goes back to what I was saying about uncertainty. Those early calculations, they were based on limited observations.
The more information we gather.
Exactly. The more data we gather about an asteroid, the better our predictions get. And for 2024 YR4, the chances of an impact in 2032 are now super low.
Okay, good. That's reassuring.
Yeah.
But why the initial scare then? Why were the odds changing so much?
It's a really good question, and it shows just how important it is to keep observing these asteroids. You see, when an asteroid is first discovered, we only have a little bit of data to go on. Imagine you're trying to predict the path of a marathon runner.
Okay.
But you've only seen them run the first mile.
I see.
As we track the asteroid and get more data, our understanding of its orbit gets better and better. Our predictions get more accurate.
So it's all about getting a clearer picture of where it's going. So 2024 YR4 is like that marathon runner, and we're just waiting to see if it veers off course.
Pretty much. 2024 YR4 is actually going to make another close approach to Earth in 2028. Astronomers will be watching it really closely. That's when we'll get a really good idea of its orbit.
Got it.
We might even be able to find something called precovery images.
Precovery?
Yeah, precovery images. These are pictures of the asteroid that were taken by telescopes before it was officially discovered.
Ah.
If we can find those for 2024 YR4, it will give us even more data points to refine our predictions. It's like seeing a few more miles of that marathon. You'd have a much better idea of where the runner's headed, right?
And that makes sense.
Yeah.
So just how big is this asteroid? Is it one of those planet killer asteroids you see in movies?
No, thankfully not. Haha. 2024 YR4 is estimated to be between 130 and 300 feet wide.
Okay.
To put that into perspective, it's about the size of the asteroid that caused the Tunguska event in Siberia back in 1908.
Ah, the Tunguska event. That's one that flattened a huge area of forest, right?
Exactly. It flattened over 800 square miles of Siberian forest.
Wow.
So yeah, 2024 YR4 is something we definitely want to keep an eye on, but it's not going to, wipe out civilization.
That's good to hear. But I'm curious, how do we know how big an asteroid is when it's so far away? We can't exactly fly up there with a tape measure.
No, we can't. But we do have some clever ways to figure out its size. One is to use radar observations. Yeah, we can bounce radar signals off an asteroid, and by looking at how those signals come back, we can get incredibly precise measurements. We can figure out its size and even its shape.
So radar is like our space sonar.
Exactly. It's like using echolocation to create a 3D model of the asteroid.
Wow, that's really cool. So we've got radar telling us how big and what shape it is. How about what it's made of? How do we know that?
That's where infrared observations come in.
Infrared.
Yep. By analyzing the heat signature of an asteroid, we can learn a lot about its composition.
Oh, interesting.
Different materials give off heat differently, so by looking at the infrared light coming from an asteroid, we can tell if it's mostly made of rock, metal, or even ice.
So we've got radar telling us the size and shape, and infrared showing us what it's made of. Sounds like we're building a pretty good picture of these asteroids.
We are, and it's only going to get better. We've got some incredible new tools coming online soon. For example, NASA is going to launch a new space telescope in the next few years called the Near-Earth Object Surveyor.
NEOCC Surveyor, right?
Yep, NEO Surveyor. And this one is going to be a dedicated asteroid hunter. It'll be using infrared to spot and study these objects in amazing detail.
That's awesome. So we've got all these amazing tools to find and study asteroids. But is there anything else we can do to actually protect ourselves from these things? I mean, besides just watching them and hoping for the best.
You've hit on a very important point. Hope is not a strategy when it comes to planetary defense. The good news is we're not just sitting around and hoping. We are actively developing technologies to deflect asteroids if we ever need to. Remember the DART mission?
Oh, yeah. That was the one where NASA crashed a spacecraft into an asteroid, right?
That's right. DART, which stands for Double Asteroid Redirection Test, was a huge success. We proved that we can actually change an asteroid's path on purpose.
That's amazing. So we're not just watching these asteroids. We're actually developing ways to, nudge them out of the way if we need to. That's a lot more proactive than just crossing our fingers and hoping for the best. But I'm curious, DART targeted a pretty small asteroid, right? Could we really deflect something much bigger if we had to?
That's the million-dollar question. DART was a huge achievement, don't get me wrong. It was a major step forward.
For sure.
But it was just a first step. There's still so much research to be done.
Yep.
Can we scale this technology up? Could we deflect a truly massive asteroid? And what happens if a deflection attempt doesn't work? What are the consequences of that? These are all questions scientists are working on right now.
So it's not like we've completely conquered the threat of asteroids. But DART shows we're definitely heading in the right direction.
Definitely. And we're not putting all our eggs in one basket.
Mm-hmm.
Scientists are exploring a bunch of different ways to deflect asteroids. We've got ideas like using gravity tractors and even lasers.
Wait, gravity tractors? Lasers?
Yeah.
That sounds like something straight out of Star Wars.
It does, doesn't it? But they're real technologies, and they have the potential to completely change how we protect our planet.
Okay, I'm definitely intrigued.
I knew you would be.
Tell me more about these sci-fi sounding solutions.
Well, we'll have to save that for part 2 of our deep dive. Welcome back, everyone. So, before the break, we were talking about some pretty futuristic sounding technology, like those lasers. When we think about deflecting asteroids, lasers sound a little bit like a science fiction movie.
Yeah, a little bit. But you said scientists are taking this idea seriously.
Oh, absolutely. It's definitely something they're looking into.
Okay, so I have to admit, the idea of using lasers to deflect asteroids sounds awesome.
Yeah.
But how would it actually work? Would we be, blasting asteroids into pieces like in the movies?
Not exactly. Blowing up an asteroid might look cool on screen, but it could actually make things worse. You'd end up with a bunch of smaller pieces, which could still be dangerous. The goal with lasers isn't to destroy the asteroid, it's to gently push it off course.
Okay, that makes sense. But how do you gently push something with a laser?
It's all about physics. When you hit an asteroid's surface with a really powerful laser, it vaporizes a tiny bit of the material. That creates this plume of superheated gas, like a tiny rocket engine. And that thrust gently pushes the asteroid in the opposite direction. It's like using a really small, controlled explosion to steer the asteroid away from Earth.
Wow, that's incredible. So you're basically using physics to solve this cosmic problem.
Exactly.
What about those gravity tractors you mentioned? Those sound really interesting, too.
Oh, yeah, gravity tractors. Those are even more subtle. They'd basically use the incredibly weak gravitational pull of a spacecraft to slowly tug an asteroid off course. It would be like a cosmic tow truck.
A cosmic tow truck. I love it.
Right. Gently guiding that asteroid to a safer path.
So we park a spacecraft near the asteroid and just let gravity do its thing. Sounds pretty simple, but how long would that take? I mean, wouldn't it take a really long time to move an asteroid that way?
That's the catch. It could take years, even decades, to really make a difference. That's why it's so important to find these potentially dangerous asteroids as early as possible. It gives us enough time to put these plans into action.
Right. Early detection is key.
Absolutely.
But with all these different options being explored, how do we choose which one to use? Is there like a one-size-fits-all solution for asteroid deflection?
I wish it were that easy. But unfortunately, no. Each asteroid is different, right? You've got size, composition, trajectory, and then, of course, how much time we have to act. It's like having a toolbox full of different tools. You got to pick the right one for the job.
So it's about choosing the right tool for the job. Okay, that makes sense. But are these technologies really, feasible? Are we talking about real solutions here, or is this all just theoretical?
It's definitely moving from theory into reality. The tech we need for both laser ablation and gravity tractors is getting better all the time. Like, we're making huge strides in high-powered lasers, new types of spacecraft propulsion, autonomous navigation, all super important for these techniques.
It's pretty exciting to think about. We're on the verge of having these incredible tools to actually defend our planet. It's like we're entering a whole new era of space exploration, not just observing the universe anymore, but actually shaping it.
I love that. And what's even more incredible is that this whole planetary defense thing is bringing together scientists and engineers from all over the world. It's a truly global effort. We're all working together on this, It kind of transcends national boundaries and unites us with this common goal of protecting our planet.
That's inspiring. Something as potentially terrifying as an asteroid threat could actually bring humanity together like that.
Right. It really shows what we're capable of when we work together.
Absolutely. We really are all in this together, sharing this one planet. But with all this talk about deflecting asteroids, are there any, ethical questions we need to consider? I mean, who decides which asteroid we try to deflect and how? What if something goes wrong and we accidentally make things worse?
These are all super important questions, and the ethical side of planetary defense is something we need to think about carefully. As we develop these incredible technologies, we also have to establish some ground rules, international guidelines and protocols to make sure we're making responsible decisions.
So we need to have a global conversation about all of this.
Absolutely. This isn't just a science and tech issue, it's a societal issue too.
Well said. Okay, I feel like I'm getting a much better understanding of the science and technology behind all of this. But I have to admit, I'm also feeling a little overwhelmed by the sheer scale of it all.
I get it. It's a lot to take in. The universe is vast, and thinking about cosmic threats like asteroids can make you feel pretty small. But I think it's important to remember that all this work we're doing in planetary defense, it's really a testament to how amazing humans are. We're not just passively sitting here, we're taking action. We're taking steps to protect ourselves and future generations.
That is inspiring. We really have come a long way in understanding these threats and figuring out how to deal with them.
We have. And, it's not just about asteroids either. All this knowledge and these new technologies, they have so many other applications, too. It's helping us learn more about how our solar system formed. It's opening up new frontiers in space. And we're even looking at ways to use asteroids for things like resource extraction.
Whoa, wait a minute. So you're saying we could actually mine asteroids for resources?
Exactly.
Like what?
Well, think about it. Asteroids are basically these giant chunks of metal and other materials just floating around in space. Some are loaded with valuable metals like iron, nickel, platinum, stuff we need for all sorts of things. And some even have water ice, which can be broken down into hydrogen and oxygen.
Which is what we use for rocket fuel.
Exactly. So imagine a future where we're not just deflecting asteroids, but actually using them to build and fuel our spacecraft in space.
That would be amazing. Okay, so we've covered a lot of ground today. We talked about the threat from asteroids and all the cool ways we're learning to protect ourselves. We talked about lasers and gravity tractors and now asteroid mining. This is blowing my mind.
I told you it was going to be a wild ride.
You did.
Yeah.
Ha ha. So what's next? Where do we go from here?
Well, we've talked a lot about asteroids as a threat, but like we just touched on, there's another side to all of this. Asteroids aren't just potential dangers, they're also incredible opportunities.
Opportunities. I'm all ears.
We'll dive deeper into all of that in part 3 of our deep dive. It's going to be fascinating, so make sure to stick around.
Welcome back, Space Explorers. Over the last 2 parts of this deep dive, we talked about the potential dangers of asteroids and all the awesome ways we're learning to protect our planet. But like you said before the break, there's another side to this story, right? Asteroids as opportunities. I'm ready to hear more about that.
Yeah. It's pretty amazing when you think about it. Forever we've seen asteroids as these scary things, these things that could cause a lot of destruction. But now we're starting to see them as something else, these like cosmic treasure chests, full of valuable resources that could totally change how we explore space. They could even help us back here on Earth.
Okay, you've definitely got my attention.
Yeah.
What kind of resources are we talking about here?
Well, think about it. Asteroids are basically leftover pieces from when the solar system was forming. Some of them are packed with metals like iron, nickel, platinum, the stuff we need for all kinds of technology.
And some have water ice, right?
I got it.
Great.
Water ice can be broken down into hydrogen and oxygen.
Rocket fuel.
Exactly.
So are you saying we could mine asteroids for the materials to build and fuel spacecraft?
Yeah.
Like right there in space?
That's the idea. Imagine building a moon base or a Mars colony using stuff we get directly from asteroids. It would make those deep space missions way cheaper and easier.
Wow, that's mind-blowing. That would totally revolutionize space travel. But how would we actually mine an asteroid? We can't just send people up there with pickaxes, right?
Ha ha, right. Asteroid mining is seriously complicated, but engineers and entrepreneurs, they're coming up with some pretty ingenious solutions. Some people are thinking about catching a small asteroid and putting it in a stable orbit, maybe around Earth or the moon.
Okay.
Then it'd be much easier to mine. Others are working on robotic mining, like autonomous spacecraft that could do the mining and processing right there on the asteroid.
Robotic asteroid miners. Okay,
Yeah.
now that is straight out of science fiction.
I know, right? It's super cool. But the big question is, can we actually make money doing this? Is asteroid mining a real possibility or just a cool idea? Well, it's still pretty early, but the potential is huge. Some estimates say that the resources in just one asteroid could be worth, get this, trillions of dollars.
Trillions. Okay, now I understand why everyone's so excited about this. But what about the environmental impact? I mean, if we start messing around with asteroids, are we going to mess up the solar system somehow?
That's a really good question. And it's one that, that everyone's thinking about. We're already seeing the effects of messing with our environment here on Earth, so we have to be really careful in space, too. Any asteroid mining has to be done in a way that's sustainable.
Right, so we need to find a way to use these resources without messing things up. It's like that balance we're always trying to find here on Earth between using resources and protecting the environment. So it sounds like this asteroid mining thing has a ton of potential, but there's still a lot to figure out.
Yeah, for sure. Like any new technology, we got to be cautious and think about the risks and the benefits.
Yeah. Well, this has been an amazing conversation. We've talked about the threats from asteroids, all the cool tech we're using to protect ourselves, and now the potential for asteroid mining. It's just incredible. So for anyone listening who might be feeling a little bit overwhelmed by all this, what's the main takeaway you want them to remember?
I'd say keep looking up and keep exploring. The universe is this amazing place full of wonder and possibilities. And yeah, there are challenges out there and risks, but are also unbelievable opportunities to discover things, to invent new technologies, and to work together.
I love that. So keep your eyes on the skies, everyone. Let's work together to create a better future for everyone, both here on Earth and out there in space. This has been an incredible deep dive into the world of planetary defense and asteroid opportunities.
It has.
We hope you learned something new today. Don't forget to subscribe for more space news and planetary defense updates. And be sure to let us know your thoughts about asteroid threats and opportunities in the comments. Until next time, keep exploring.